So I do have a blog, and it's on scienceblog.com, and it comes out every Tuesday. And in it, I talk about, well, I'll get to that, but first, a little background, which David already gave you. So I have a PhD from Tufts University, where I looked at carbon sequestration in temperate forests. And then I went on to do a postdoc at UC Davis looking at climate change in vineyards and viticultural systems. And so now, by day, I work at the National Center for Science Education, where I'm a superhero, and I fight to defend science education. So that's actually what I look like during the day. I have blonde hair, and I'm very muscular, and I'm flying through the air. And then by night, and there I go. And then by night, I look like this, and I'm a super nerd. And I sit behind a stack of books. So it's sort of the opposite of the typical superhero character. And what I write about for my science blog is the unexpected and unusual effects of climate change on biological systems. So we all hear about some of the more standard effects of climate change, but there's actually all sorts of really interesting research going on about sort of some of the more quirky things that are going to happen with climate change. So I'm going to talk to you about only a couple of those things tonight, but you can go to my blog or you can talk to me after this. There's so much research out there. It's really interesting. So having been a teacher and during my graduate work, I'm used to being in the spotlight, but I'm also used to putting everyone else into the spotlight. So there's going to be a lot of me asking you questions. So I realized that you thought you came just to listen to me, but I actually came to listen to you. So I wanted to throw out the first question. So I'm not going to go through climate change and how it works on a global scale, because I'm assuming everybody here understands that. But I was wondering if you guys could tell me what some of the expected changes are, because I'm assuming you know. So one, for example, temperature. What's another one?
Sea levels rise.
Sea level rise. All right, give me another one.
Extreme weather.
Extreme weather events. Any others? Changing crops. Extinction of animals. Okay.
Water shortages.
Migration of animals. Okay. Sorry? Imbalance of animals, that sort of thing. So I'm going to talk about some of those things. So I was thinking more about some of the abiotic changes that we're going to see. So the ones that I've picked out that generally people talk a lot about are changes in precipitation patterns, changes in temperature. The one on the bottom there is ocean acidification, which I'm going to talk a little bit about tonight. Changes in greenhouse gases like carbon dioxide. And then sea level rise is that hilarious tidal wave in the corner there is symbolized by that. But I think somebody mentioned sea level rise as well. So from a biological perspective, this is actually really interesting because all of these variables have the potential to affect biological systems. So it's a whole new suite of questions that you can start asking, and people are starting to do that. So I'm going to give you an example right now. The greenhouse gas, carbon dioxide. People know that trees and plants use carbon dioxide as part of photosynthesis. This is sort of not exactly new. But if we're going to have more carbon dioxide in the atmosphere, then can you predict or hypothesize that trees would grow more because they would be taking in more carbon dioxide? And then that would solve all of our problems and we could all go home. So my question to you is, how would you study this if you wanted to ask that research question? What would you do? All the way in the back. Oh, look to see like all the way in the paleo record? Sure. Has this ever happened before?
Leave a house plant in the garage with the engine running.
That's, well, okay. Be careful with that. Yeah, and, right behind you and then in front. Yeah. Tree rings. Look at tree rings and try to compare to how much carbon dioxide was in the atmosphere at the same time. Okay, so we have a lot of ideas about paleo and so on. Some researchers did this. This is a forest. This isn't paleo. This is more recent than that. This is a forest in North Carolina where they're pumping carbon dioxide into the forest at high levels to see what the effect on the forest was going to be. Has anyone heard of this study? Well, all of your tax dollars paid for it, so thank you very much. So what did they find when they did this? Well, the study's been going on for, I want to say about 20 years or 10 to 20 years, for a really long time. So they have very strong research that has come out of it and really interesting information. So I'm only going to talk about one piece of it. So what they found was initially there was a carbon fertilization effect. So the trees did take in more carbon when there was this increased carbon dioxide in the atmosphere, which is really interesting, except trees don't exist in a vacuum of carbon dioxide, and they don't only need carbon in order to grow. What else do they need? Nitrogen. Well, wait a minute. Okay. And these forests in particular are nitrogen limited. And so the forests started running out of nitrogen available to the trees, and the trees stopped seeing that fertilization effect. So all the policymakers who about 20 years ago said, oh, it's not a problem, the trees will just grow more and they'll take in all the carbon dioxide, the scientists actually wanted to answer that question, and it turns out that there was this limitation. And so one of the challenges, though, with this kind of study is I showed you all those variables earlier, and I only am talking about one variable here, carbon dioxide. But there are other variables that come with climate change that are going to influence forests, such as changes in precipitation pattern and temperature. And so a lot of the studies that I'm going to talk about today are looking at one or two of these variables. And so what people do typically is they use that research to start building bigger answers to their questions. And so when I'm talking about wine later and I'm only talking about temperature, people might say, oh, no, but what about carbon dioxide? Or what about this and what about that? And so I don't have time to talk about all the studies, but these are sort of the place markers or the first steps to answering the larger questions. The other thing to point out, especially when I'm talking about wine, are there any wine enthusiasts here? Oh, perfect. Excellent. So your arm might shoot up and say, oh, but Cabernets are different from Zinfandels, and where that Zinfandel is growing is going to have a major effect on the different flavors and that sort of thing. So it's important to keep in mind that I only have an hour, so there are going to be some generalizations that are made, but I'm happy to talk to you more about it afterwards as well. So climate change and food, we're going to start off by talking about. And most of the time when you hear about climate change and food in the press, it's about yield. So the quantity of the food is what we're interested in because we're trying to feed millions of people and so on. So it's totally understandable. But there are lots of foods that the most important aspect of them is not how much you can grow or get or stuff in your stomach. It's really the quality of the food. So for example, chocolate or cheese or wine is what makes it more expensive, and that's going to be what's more important in some cases for the person who's producing it. So I'm going to talk about not quantity, but quality today. So the quality of food and wine in particular. So I asked David to be my assistant, and I got a glass of wine. And he's going to he's going to taste some wine and tell us about the different flavors that he's experiencing. You can use the microphone if you want.
Definite tartness reminding me of persimmons.
Tartness?
There's a cinnamon overlay.
Okay. Excellent.
And definitely the aftertaste, that tartness of persimmons.
Okay. Would you say, is it a sweet wine or is it more of a dry wine?
It's relatively dry.
Okay.
Yeah. The tannic acid gives it that dry feeling.
Okay. And I think those are, and looking at it through the light, what colors do you see? It might be hard to see in here. It looks pretty robust and dark, but.
Yes, definitely. It's darker than ruby.
Yeah, okay.
It's closer to garnet.
Ah, there we go. Oh, now it's just fancy. Yeah. Thank you. You can finish that too. I thought that's special. Other people who drink wine in the audience, I saw 2 hands shoot up. What are the things that you look for in your wine? I'm putting you on the spot.
I like the boldness of the wine.
How bold it is. So you're interested in more of like a Central Valley kind of California, like really punchy, hot, almost hot area wine. And who else? Oh, sorry.
Sorry.
No, go ahead.
Cellar tasting, basement kind of.
Oh, like it has like a.
That's the only way to describe it. It's like you're like tasting dirt.
Some like a little bit of like a bassy tone. Okay.
I like bold and smooth.
Bold and smooth. Yeah. So maybe not very acidic. Would you say?
Yeah.
Maybe like that. And who else? Yeah. Okay.
I like balance, so all the different characteristics are kind of
Oh, like in perfect harmony.
not necessarily, it could be slightly off balance.
Okay.
Interesting too. So it's kind of balance is good, and then also uniqueness, something that stands out. You don't want an acidic wine if you're having something mild, but if you're having Italian food, you want acidic wine to kind of balance the acid.
Oh, so you look for a good match for what you're eating. Excellent. Yeah. Yeah, so these are the things I actually, in preparation for this talk, I was going to print out a sheet of all the different flavors that people use to describe wine, and it was like going to be 30 pages, so I decided that wasn't. And among them is wet dog. I didn't realize this. So I don't think that's one of the preferred flavors. I think that's if something goes wrong. But yeah, you don't look for wet dog in your wine. Okay. Yeah. But these are the things that when I'm talking about quality versus quantity, if you want quantity, you can go get a box wine, but we're not going to sit here and talk about the different flavors that are coming out of it. But if I want to talk about quality, people are willing to pay a lot of money for that, and this is why it becomes so important. And so the concept of I can never pronounce this right. Terroir. Am I doing it right? Terroir. Who knows what that is? Can you explain? Somebody? Okay. Where it was grown. That what?
Specific details of where the grapes were grown. So is it on this side of the hill or that side of the hill? What which is nearby? This is kind of a very French concept.
That's why I can't pronounce it. It's French. So I took Spanish. So I can't do the French. But yeah, it is. It's this idea that where the grapes are grown, the geology, the geography, and also the local climate is really going to influence the flavor. And so some people say, yes, this is totally a thing. Some people don't. We had somebody who was a wine connoisseur at our house over dinner, and we did a blind taste test, and he really could tell us where that wine came from. So I'm more on the convinced side than not. I don't know. Well, yeah. But anyway, but the thing about terroir is that with climate change, the geology and the geography is going to stay the same, but the climate is going to change. And that's certainly a concern to wine growers in California and in other areas as well. So there's obviously, we talked about a lot of different flavors and what people look for in wine. There's many different components that play into that. I'm only going to talk about a few because, like I said, my time is a little bit limited here. But if you're interested, I can definitely talk to you about it more later. So the things I'm going to talk about are sugars, tannins, anthocyanins, and acidity. And so sugars are really, and I'm sorry, I'm going to talk about the research that's looked at the effect of carbon dioxide and temperature on these different flavor components, or anthocyanins are more the color, but the quality components of that. And so I'll say first, carbon dioxide I'm going to take out because there was a really great study that was set up that was just like that forest study I showed you before, the FACE study. But they did it in vineyards where they pumped carbon dioxide into the vineyard to see what the effect would be. And the only effect that they saw was that the berries were bigger, but it didn't change the quality components of the berries. So I'm going to talk about just temperature. So with sugars, which affect the sweetness but also affect how alcoholic the wine is, in higher temperatures, the sugars tend to go up. So these are the things that we were talking about with wanting like a Central Valley wine, a really hot area wine, that sort of thing. Those wines, those grapes tend to be higher in sugars because of the higher temperatures. And so under higher temperature, sugars go up. Meanwhile, acidity goes down. And so those people who are not into more acidic wines, then maybe this would be a good thing. And then tannins, which are the flavor components that when I asked David about if it was a dry wine or not, these are the things that tend to make your mouth feel a little bit dry. So they're really common in tea. So if you have a really dry tea, your mouth might be like very dried out. They tend to go down in higher temperature, but the research is a little bit out on that. So more studies need to be done in order to actually determine that. And the same thing with anthocyanins, which are responsible for the color. And so this is another thing that if you're just drinking the wine, you might not care about this, but if you're a true connoisseur, certainly color could come into play as something that you're interested in. And again, this is only from one study that I was able to find this, and so I didn't feel confident enough to be like, absolutely with all wine you're going to see this, but there is that trend. So what are the practical implications for people who maybe don't care about wine or think that this is a little bit silly when we're concerned about larger issues of actually providing food for people? And so the quality compounds like tannins and other phenolic compounds that you find in grapes and in the leaves of plants, these actually originally have other biological purposes. And these are as defensive compounds against insects eating them. And so if you're changing the environment, which is having an effect on these different components, then it will also have an effect on the insects that are able to or not able to consume your plants. Okay, so now we're going to go underwater. That was the terrestrial part. And we're going to go underwater and talk about ocean acidification. Has anyone heard of ocean acidification? Yeah, I have a really brief video about it, and I think they just do a really nice job of summing it up and summing up what the implications are. So I'm just going to play it really quickly. Let's see if the audio works.
Pteropods, or sea butterflies, are found throughout the ocean and are a major food source for fish and other organisms. In laboratory experiments, this pteropod shell dissolved over the course of 45 days in seawater adjusted to emission chemistry projected for the year 2100. What changes in the ocean might be putting pteropods at risk? The burning of fossil fuels has caused levels of carbon dioxide in the atmosphere to rise. This carbon dioxide, or CO2, doesn't just stay in the atmosphere. Roughly 30% of it is absorbed by the ocean. When CO2 reacts with water, it forms carbonic acid, which quickly releases a hydrogen ion, or H+. The more hydrogen ions, the lower the pH, or more acidic a solution is. As CO2 levels increase over time, seawater will progress towards the acidic end of the pH scale, a process called ocean acidification. We can make projections of this change in the ocean pH over time. It is expected that later this century, if CO2 emissions continue at the current rate, the average pH of the ocean will drop from 8.2 to 7.8. This relatively small decrease in pH may not seem significant, but it could impact many species of marine life. For pteropods, corals, and other species that depend on shells and exoskeletons, ocean acidification will lead to a decreased availability of dissolved calcium and carbonate, the chemical building blocks they use to make their shells and skeletons. If ocean chemistry changes as expected, Shells with calcium carbonate mineral structures may begin to dissolve, depending on where they live and which.
Okay. Okay, so that basically sums up ocean acidification, how it happens, and why it might be problematic. So in that case, they showed us pteropods, but there are other shelled organisms in the ocean. For example, snails. So snails do this really interesting thing when predators are around. They actually have olfactory cues, so they can essentially smell or do an underwater sensing of predators. And what they do in response is they thicken their shell, which totally makes sense because if your shell is thicker, then the crab can't crack you open and eat you. This is a natural defense that they do. So what happens when the water becomes more acidic? They lose the ability to thicken their shell. So this is problematic for the snail because if it can't thicken its shell, when a crab is present, the crab can break right in and eat it. It's not a problem. So what does the snail do? It takes off and it runs away. Snail is safe, everyone's happy. But what are the larger implications of this type of study? Could you imagine what other things would come of this? What are some hypotheses that you could come up with, or some research questions about what would happen?
Snail invasion.
Snail invasion. Of where? That's a good question. Yeah, it's, so the whole idea with ocean acidification is it would be harder for shelled organisms to be building their shells. So yeah, I mean, they might also have thinner shells. The whole thing with this one is this study was that it's a behavioral response, basically, or it's a defensive response. So normally they're doing a biological defensive response. But they can't do that, so they do sort of a behavioral defensive response, taking off. So the implications are that all of a sudden the things that the snails are eating in that one area aren't getting eaten anymore, so whatever slime is developing there, so it could have ecosystem effects. It could have an effect on other types of shelled organisms and how they respond to predators being present. So sort of larger scale implications for something as little and tiny and adorable as a snail, or gross to some people, but not to me. So other organisms as well in the ocean have, there's been some interesting research on them as well, including Nemo, I guess, clownfish. And it also has to do with olfactory cues, so their ability to sense other things in the water through smell. And so there was a couple of really great studies that came out that basically we already know that clownfish can sense when they're swimming around looking for a place to call home. They can sense where sea anemones are, and they'll go set up shop there, and they're attracted to it. So, and they can also sense where other clownfish are, but they try to avoid their parents. So if they smell that their parent is there, they'll actually take off. And they also avoid predators. So if they smell or they sense that a predator is there, they'll take off as well, which is great because that's how they survive. But clownfish in more acidic ocean or more acidic water actually have a different response to these cues. So for sea anemones, they still are attracted, but just not as strongly to the sea anemones. So still okay, they can probably find a home. Sort of frighteningly to their parents, they're suddenly attracted to where their parents are. So suggesting that, they might end up mating with their parents if they end up in the same spot. So that's a little bit hinky. Yeah. And similarly, they're also attracted to where predators are. So all of a sudden, oops. So all of a sudden you have clownfish that previously were avoiding their parents and avoiding predators so as not to commit incest and not be eaten. And in this more acidic ocean water, they're actually being attracted to it. And so what happens when you make the water even more acidic? Well, then the clownfish just kind of swims around confused and at the end of the little tank that they had it in and didn't really make any decisions at all. So poor little confused clownfish swimming around, I don't know, getting eaten, having sex with their parents. I'm not sure what they're going to end up doing. So what are the larger, oh, sorry, go ahead.
Just looking beyond the scope of this
Yeah.
talk, but is this part of this acidification problem what's going on with the coral?
Yes, so
Can't grow, the calcium that they need to build is not.
yeah, that's a good question. I actually know less about coral. So the question was, is ocean acidification or the same issue what's addressing coral? So, or the problems that they're having with coral right now. So there's a couple things that are going on with coral, and I think one of the big ones is the bleaching that they're experiencing. I don't know if you've heard about that at all. And I think that's a major concern. I think that any shelled organism in the ocean is going to be affected. And so a lot of the research, the snail research was just one of many studies that are going on where they're sort of like, okay, what are these organisms going to do? Yeah, that's a great question. Okay, so the final one that I have is jellyfish. I'm sorry, not jellyfish, jellies, right, because they're not fish. Right, yes. Yes. If you don't give it the right name, you might think that they have a backbone and are swimming around and, you know, having incest with their parents or something. I don't know. So jellies, right. So I don't know, has anyone heard about increased jelly outbreaks as sort of some people have, some people haven't. I was hearing it in the news within the past couple years, which is why I was interested in looking into it, because some people were like, oh yeah, it's definitely related to climate change, and so I wanted to look into it and see whether or not it was. So I have a brief video of a jellyfish life cycle. But I'm going to turn down the audio because it's this weird hippie sort of music going on. So anyway, so the sperm and the egg meet, and then they become a larva. It becomes a polyp, which sits on the ground, attaches itself to the ground. And then, this was someone's animation project. There's the strobila phase, where these little sort of pre-jellyfish pop off. And the phyra are swimming around, and then the medusa, which is what you're more familiar with. So I kind of like this video because actually before I took a marine invertebrates class, I had no idea that jellies actually had these other parts of their life cycle. But it's really important when you're thinking about an organism like that, because there's a lot of different opportunities for something to happen, either to support their existence or to take away from their existence in some fashion. So to really affect the jellyfish. Jellies, sorry, not jellyfish. Right, jellies. So those who've heard about an increase in jellies over the past couple of years, what have you heard in terms of the causes of it? Have you heard anything? Lack of predators? Like, because, yeah?
Excessive some things, like turtles really like to eat them, so they gather. That displaces some other.
Yep. Yeah. So, and overfishing, which would be good for the jellyfish. So removing predators or competitors also. Yeah. Any other things that you've heard? Well, like low oxygen environments. Okay. And so knowing that there's this floating part of the jellyfish and this sort of stationary part of the jelly life cycle, can you think of anything else that might affect the stationary part of the jelly life cycle?
Well, just in general, I wonder if the change in pH might affect the development cycle.
The change in the pH in the so what you said was, would the change in the pH affect the development cycle in some way? Would temperature affect the life cycle? I mean, these are all the questions that people are asking, right? So the first thing I would say is that humans have made this really fantastic environment for jellies because they have this sedentary phase, this phase where they're attached to the ground, by creating something called ocean sprawl. So jellies, when they are swimming out as a larva, looking for a place to set up a home as a polyp, are looking for, I don't know, solid ground to attach themselves to, which we provide by building out bridges, by building out docks, by building boardwalks, and so on. These are all the things that are increasing. And then the polyps can just like happily live there for as long as they want to. The other thing that's going on is what Will mentioned, eutrophication and hypoxia. Is anyone familiar with eutrophication? Have you heard of this before? I have a short video that just talks about that as well, which I think they do a nice job of summing it up. See if I can turn up the volume on this.
One microscopic aquatic organism plays a major role in making life on Earth possible: phytoplankton.
If it weren't for phytoplankton, the Earth as we know it would probably not be able to exist. Life on this planet pretty much depends upon phytoplankton.
Light and the presence of nutrients in the surface waters make phytoplankton growth possible. Physical processes like ocean circulation and upwelling help to regulate the distribution and abundance of the plants. For the last decade, scientists have used satellite measurements of ocean color to determine the global distribution of phytoplankton and to begin to link its variability to environmental factors.
The beauty of studying the oceans from space in a consistent way that satellites allow us to do is that you can study phenomena both on different time and different space scales.
Using data from an instrument called CWIS, researchers observed that both natural and human-induced events cause levels of phytoplankton to shift from their usual rhythms. Under certain conditions, excessive phytoplankton growth can result in an area known as a dead zone. Dead zones form when big blooms of phytoplankton at the surface trigger large quantities of organic matter, which then sink to the bottom. Bacteria break down the organic material, releasing carbon dioxide but absorbing oxygen as they work. Most marine organisms need oxygen for survival, and dead zones can be fatal for many aquatic species. Many human activities on land trigger the seasonal appearance of dead zones. Fertilizers run off lawns and cornfields. They seep into the network of rivers and streams that comprise a local watershed and provide a jolt of nutrients to phytoplankton that edge the shore. The Mississippi River watershed drains directly into the Gulf of Mexico, where dead zones frequently occur. Satellites cannot actually see dead zones, but they can monitor the distribution and abundance of phytoplankton, including conditions that may lead to phenomena like dead zones. There is no question that the Earth is changing. In the decades since its launch, CWIS has enabled us, for the first time, to monitor the biological consequences of that change, to see how human activity and how natural variability affect the Earth's ability to support life.
Yay, NASA, for making us really great videos. Okay. So eutrophication and hypoxia. So the way that it affects jellies actually is the things that you guys were talking about before. So you did a really nice job of identifying some of the things that are actually benefiting jellies. Is that eutrophication and hypoxia do a nice job of eliminating the competitor fish. So knocking them out because they can't, they don't survive as well in these low oxygen environments, whereas some studies have shown that jellies actually aren't nearly as strongly affected by these kinds of environments. And then also, eutrophication, what ends up happening, as you saw in the video, is that it alters the phytoplankton, but it also can shift the community to favor species that jellies actually prefer. So they have fewer competitors and they have more food. So then that'll make them do better as well. And so then talking about the climate change aspect of it, well, after looking at ocean sprawl and eutrophication and hypoxia and any number of other effects, how can you say that it's climate change as well or not? And that becomes really tricky because, so there are changes in the food availability when the temperature changes in the ocean. So that could definitely benefit a jelly. And temperature has been shown to change the budding of the polyps and that sort of thing. And it can also disrupt competitors. But the challenge that researchers are having right now is identifying which of these factors is really driving the jelly's success, because it could just be a perfect storm of all these different aspects. And what the jelly's example really demonstrates is the humans as a force of nature, in that there's all sorts of different aspects that are going into benefiting the jelly. So it's not just climate change anymore, but it's all these different components as well. And that's all I have to talk about today. But I'm happy to answer any questions if anyone has any. Thank you.
This might seem naive, but I don't know anything about jellies.
Sure.
Why is it bad to have so many jellies, other than I know some of them sting us when we go into the ocean?
That was your question. You can answer that.
I didn't know it. I was just worried about it. I didn't know.
So that's a good question. Can anyone think of why you would want more or less jellies?
I've seen photographs of the fishermen trying to draw nets that are just full of cannonball jellies and not fish. So they seem to be a major pest species in that way.
Okay, yeah. I mean, if they're getting in the way of you being a fisherman, then maybe that might be problematic. It looked like you were going to... Sorry, go ahead. Yeah. Yeah, so she just said that it might affect the food chain. So all of a sudden you have more of one kind of animal that's either, that's eating everything, and it's going to affect the food chain. Any other thoughts? I thought I saw another hand, but yeah. I mean, all of those things come into play for sure. And I think that definitely the stinging component, I think, is why a lot of people tend to complain the most about jellies for sure.